Good morning, good afternoon, and good day to everyone. I feel myself very happy and I take this opportunity to wish our favorite young energy, Kiran, a very happy birthday. Let
Thank
him
you, sir.
flourish, let him prosper, let him develop, let him come out with successful, fine colors, and let him conquer whatever he wants in his life. So, as per his plans and strategies, and soon our wish is to see him as uniform officer in the India campus as well as off the campus. So in his
Thank you.
defense, because defense ultimately is guarding all of us. So if he joins that team, and our nation is very happy, our borders are very happy, and we are very happy. So wishing him all the very best, and let him be a winner in whatever walks of life, in whatever way, in whatever path he selects. So all the paths
Thank
are will be successful to Kiran, because Kiran is it is a, in English we call it as a radiation. So radiation of hope, radiation of energy. So with all those radiations, so he will come out, and we are there to witness his energy in different forms, in different his work power. So many happy returns of the day, Kiran, and we love you
thank
all.
you, sir.
We love you all. So okay, with happy note, today we will start uh, this session, that is the group 16th. So yesterday I told we are going to start a group 16th today, and already yesterday small idea was there. So this one is the what idea. So our next slide already I shown yesterday in our previous session. So group 16th member: oxygen, sulfur, selenium, tellurium, polonium. Oxygen O, sulfur S, selenium Se, tellurium Te or Tl, Te, polonium Pl or Po, Po. Chalcogens, ore forming. So most of the metals occur in these forms only. So percentage of occurring ores in the earth crust. So in this form only we enjoy in the earth crust. Therefore, these are called as ore forming group. Chalcogen group, halogene and chalcogen, nicogen. So all these are old literature. Okay, right. First, how they occur, where they occur. Oxygen, the first member, so most abundant in nature, whether it is earth crust, okay, whether it is atmosphere, whether it is hydrosphere in the form of ocean H2O. So it occurs in the free state as well as combined state. So most abundant element. So in all the three spheres, in all the three areas, we find oxygen. So data wise, 46.6% by weight in the earth crust. So rocky area, mineral area, ore area, but in the dry air, so what we breathe, so it is around 21%. Second major component of the dry air or the atmosphere. So all these data will tell us that it is the most abundant element on earth. Okay, and because of this only we are here. Okay, this is called as what? Pranavayu. So we do the pranayama. What is pranayama? Taking oxygen. It is a breathing techniques. Why we go for the walking or the jogging? Just to increase our lungs capacity. Let it take maximum oxygen. The more we take oxygen, the more we are healthy. Normally we take, okay, normally we take, but with some activity, if it is given properly, okay, there are techniques, walking techniques, jogging techniques, pranayam techniques, and mudra techniques. So all those techniques are there. So with those techniques, if you can take oxygen in a proper way, we are taking improper way. So if the proper way is taken, I think we get a good oxygen, and that is a pranavayu. And for Lord Hanuman, we say pranadevaru. So Hanuman is called as a symbol of energy. Okay, so pranadevaru. Hmm? Okay. So this is about the oxygen, and the second member sulfur. Second member sulfur. So sulfur also occurs, though it occurs in small amount in the earth crust, but it occurs in different variety. Okay, so sulfur is actually mined. How we mine coal? No, coal mines are there, diamond mines are there. So in the same way, we mine coal from the bottom of the earth crust. It is available at the beds, okay, lower beds. So normally, if you see the globe, where we have the active sites for the volcanoes, so there normally we find the sulfur. Okay, so they see all the geographical survey from the remote sensing. Then volcano areas are more what large deposits of sulfur will have. So there only you go for mining. Other parts are there, but less amount. Okay, so that is the what availability or the occurrence of what sulfur, and sulfur occurs in different forms in S2, S4, S6, S8, S22. Many are there, but the most stable form of sulfur is S8. Okay, so S8 is called as a crown structure, ring structure, closed structure. So that is the structure for sulfur. So that is the most stable. Others are they keep converting, they keep changing. Okay, at a particular temperature. But for a long time, the most stability after work we have done the checking. So it is the S8 is more stable. Other forms are less stable. So sulfur occurs in a sulfide form, in a sulfate form. Okay, so in the sulfide form, so in these are different forms of sulfurs in the earth crust. For example, gypsum is available, epsom is there. Okay, and the zinc blend, most famous ore of zinc, ZNS zinc blend is there. Okay, or galena, PBS, lead sulfide is called as galena. All these are metallurgical words using the Greek literature. So galena, blend, so all are related to the sulfur. So there are sulfur ores. So in particular, they are called what sulfide ores, and there are some sulfur ores. They are available in the form of pyrites. Okay, copper pyrite, iron pyrite, okay, magnesium pyrite, manganese pyrites. All these are called pyrites. Okay, pyrite is a sulfur form. Okay, so all these are available. So even whenever a volcano erupts, okay, so on some hills, so sulfur flows down. So sulfur comes out. So in the form of hydrogen sulfide S2S, then it is purified afterwards. So all those natural activity, they are not in our under control. Earthquake, volcano eruptions, all those they are happening. It's a natural process. Okay, so no one is there to control. So, but only thing is how much sulfur comes out, how much temperature is there. Depend upon that, we go for the study. Hmm. So this is what where oxygen and sulfurs are available. In the same way, in the organic matter also, where we eat, sulfur is available in different forms, such as in the egg, in the protein, garlic, onion, mustard, so hair, wool. All these organic matter contains sulfur, and we want sulfur. Sulfur powder is must for in the different forms, not in the pure form. So in the different form, we require sulfur for our body in small amounts, in trace amount. Okay, that's why nature has given sulfur in different forms in the uh, part egg form, protein form. Okay, when you see the protein part, already we studied in the biomolecules. So we have seen some small sulfur linkage, phosphodiester. Okay, so there is small amount of sulfur. In detail, if you go DNA, RNA part, you will come to know sulfur part. And the garlic also contains small amount, which is best for the health. And there are some ointments and the medicines available in the market in the medical stores. So they also contain some sulfur content. And most of the sulfur ointments are best for the skin treatments. Okay, any skin infection, whether it's a fungus infection, whether it's a leprosy, so different types of skin infections, skin disorders are treated with these drugs, and there is a special branch in the medicines. They are called what sulfur drugs. So those are sulfur drugs. Especially skin doctors will have stock of sulfur drugs in their store, and depend upon the severity and the disease. So they advise which sulfur drug is best for the particular skin. So this is about the sulfur. Now selenium occurs in small amount. Third member. Okay. So small amount of selenium also biochemically we require. Okay, then tellurium, the fourth member, is a still small amount. As we move down, availability decreases. Okay, and the last one, that is polonium, is very rare. It is called a radioactive element. So it keeps giving radiations of alpha, beta, and the gamma. Okay, but polonium is not available in the nature. So, but it is the decay product of what? Radioactive elements, especially the which one? Thorium and uranium, F block elements. Okay, they are highly unstable. Their nuclei are highly stable because of the physics rule, proton neutron ratio. They keep giving alpha, beta, gamma always continuously 24 hours. Okay, you don't feel it. They will be in the nature. So where the alpha, beta, gamma are more, there we feel some what some time of some kind of what skin disorders. Otherwise, if the area is not having any thorium or the uranium, so we are safe. Hmm. So decay product means what? Decomposition product means whenever any radioactive undergoes a decomposition or disintegration, okay, decay, it is called decay. So then it converts into smaller nuclei. In that one is polonium. Okay, so polonium as a free is not available. It is a radioactive product of some radioactive elements. Okay, but we can prepare synthetically in the laboratory whenever we require polonium. So otherwise we collect it from the decay products of what? Uh, radioactive elements. Now this one is regarding the electronic configuration of a group of 16th members, atomic number, second column, and electronic configuration. So soon after the noble gas, their outermost configuration is there. And if you see the outermost configuration, it is S2P4. General electronic configuration of 16th group is NS2NP4. And these 4 electrons in the PR what? In PR in all the 3 P subshells, PX, PY, PZ. First, as per the Hund's rule, 1 each. Then the 4th electron goes for the pairing. So therefore, 2P4 means it is 2Px2, 2Py1 and 2Pz1, like that. So group number is same. That is the 4th column. And the last column is regarding the period. So to which period they belong. So second to 6th oxygen to the polonium. Okay, all these we learnt last year under the modern periodic table. Now this is regarding the size or the radius. Okay, whether it is atomic radii or the ionic radii. So the trend is what? The trend is as you move from top to bottom, naturally size has to increase because of the extra creation of a shell. So therefore, uh, top to bottom, general trend is what? Atomic or ionic radius increases. And the data also I brought data small table here 1.52, 1.80, 1.90, 2.06, 1.97 angstrom unit, and you can see increase in the size. Okay, but small increase, small decrease, all these anomalies are due to lanthanide and the actinoid contractions are there. Okay, that we learn when D block, F block starts. Okay, and from for our mental picture to understand the size, so using different colors, just have an idea. So as we move from top to bottom, size is, this is general way of understanding the size. Please take it as a sphere. Okay, from the last electron to the nucleus, if you draw an imaginary line, and that cloud is taken as a sphere. So in this way, we understand the size. Okay, right. Now this is regarding what? Trend in the IE, ionization enthalpy or ionization energy. Okay, so in the group we have studied that due to increase in the size, IE decreases. Okay, so as you move from top to bottom from oxygen to polonium, so we find there is a decrease trend in the ionization enthalpy, and the reasons are well known. Okay, and graphically or with diagram, it is confirmed in terms of kilojoules per mole. You can see the first one having highest IE as you move down yellow part, the bar graph. So they have less IE. Okay, right. So oxygen to polonium size increases, IE decreases. So here and there small hiccups, small variations are there. All those variations, so we explain either in terms of inert pair effect or in terms of the shielding effect or in terms of the F block or the D block entry, their shapes, they are spreading in the space. So all those matters, and we keep moving. But in general, it decreases from top to bottom. So this is what general trend is seen in the group 16th. And this is regarding what? Electron gain enthalpy. So when electron is gained by an atom, it becomes a negative ion. Okay. So it is easy to add, it is easy to remove electron. Okay. But adding is very difficult. Already there are some electrons. Okay. Already there is some electronic atmosphere is there. So with the existing electronic atmosphere, how to add is the problem. So it depends upon individual atom. So what type of environment is there. So when we go to new place, so first you understand the environment. If you have got a job in the different area, so then we'll go first month is adjustment, then second month we start working in a nice way, comfortable way. So this is all called atmosphere environment matters. In the same way, in the case of electrons also, so adding or the incoming electron to already existing system, so it will experience some kind of difficulties or happy. So all those will happen, but ultimately electron gain enthalpy in what? It is the energy change involved when atom accepts gains electron. Okay, but if you see the table, so it is having less negative electron gain enthalpy. Okay, here minus or plus or no way connection to the mathematics. Okay, right. So if you see, it is minus 141 kilojoules per mole. If you compare electron gain enthalpy of oxygen, the first member, with other members, it is less negative. What do you know? Less negative means it is not ready to accept electron. That is the meaning. Large negative value of electron gain enthalpy means what? Means easy to add electron. Okay. Less negative value of electron gain enthalpy means some difficulty is there. So because oxygen is small in size, oxygen falls in the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, then neon. Okay. So excluding the helium neon group, 18 group, this is the second leftmost element. Second rightmost, and second topmost. Fluorine is the first topmost, right side. So fluorine is the smallest in size because it is extreme right side. Next to fluorine is oxygen only. Therefore, because of its small size, more electronic density or the cloud around the oxygen nucleus. So for the incoming electron, it is difficult. So it will experience some kind of repulsions, some kind of rigidity from the existing electrons. So that's why it is slightly reluctant, but it will accept, no doubt. It will accept. Okay, but how, with what intensity, with what magnitude, with what happiness it accept, that is important here. Okay, so the data says minus 141 kilojoules per mole. The data says it is slightly less reluctant compared to other members. That is the idea behind. So electron gain enthalpy for oxygen is less negative. Now trend in the electronegativity. Trend in the electronegativity. Electronegativity is the ability to withdraw the shared pair of electrons. Electron gain enthalpy and electronegativity both are different. We discussed in the last year. There is a periodic trends on the modern periodic table. So you can equate electron gain enthalpy to electron affinity. Both are almost same, but you don't equate electronegativity with electron affinity. Electron affinity is accepting electron, okay, to convert into negative ion, whereas electronegativity is after becoming the bond, after becoming the compound. So electrons between the two atoms, so where they lie, near what, that is electronegativity. Okay, the one which is more electronegative, towards that both electrons lies close to that atom. Okay, so it is the ability to pull, to withdraw shared pair of electrons, that is what electronegativity. Normally if it is small size, okay, so they drag, they withdraw powerfully compared to the other members which are bigger in size. Okay, and as you move from top to bottom, and we have seen in the atomic size that size is increasing. The size is increasing, so the ability to pull also decreases. That means electronegativity trend is what? Trend is from top to bottom it decreases. So most of the electronegative elements we find right top, right top. Even in the left side alkali and the alkaline earth metals, they are most electropositive on modern periodic table. In their group only, if you see the the what the top one, the begin in the case of alkali it is lithium, and in the case of alkaline earth metal it is beryllium. So there, due to their small size, they will have some covalent character. Once again, here comes the help of our friend Vivek, Fossen's rule, who has studied. So more the polarizability, more is the covalent character, and more covalent character is there, they go for the sharing of electrons, and when they go for the sharing of electrons, they withdraw those shared of electrons. Okay, so electronegativity is there with all. It is the research work of the most what brilliant and the brilliant scientist of the modern chemistry, Linus Pauling. Okay, so that's why electronegativity is measured on his name. So Pauling scale of electronegativity. So Linus Pauling's work is wonderful. It has played a very key role in deciding the properties. That's why he has given Nobel Prize, Linus Pauling. So that Pauling scale is there, and what he said, electronegativity is there with all. Only thing is what? With some are having less, some are having more, some are having moderate. So with everyone, when you say that a particular element is having less electronegativity, what? It is having more electropositive character. So when it is having more electropositive character, it will want to lose electron. So oxygen is more of electronegative than electropositive. That means it wants to share, it wants to gain rather than losing electron. Whereas in the case of carbon, if you see the position is exactly in between. Okay, so the position of the carbon matters a lot. It is in between donation and the acceptance. So therefore, for the carbon, it is very difficult to give also, very difficult to accept also. Therefore, it prefers one more way, that is sharing way. So that's why most of the carbon compounds are sharing, that is covalent compounds. That we can explain on the basis of what electronegativity also. So carbon is moderate electronegative. That is the plus point. That is a gift. Okay. So where there are some moderate properties are there, no, it's actually gift only. See, in the case of metalloids, they are neither metals nor non-metals. So this moderate property, intermediate property, it is helping in the semiconductor technology, electronics. Okay, they are the kings. So we don't want extreme electroconductivity. We don't accept simply is low. We don't want superconductivity under extreme condition. Okay, and low conductivity insulators. But this moderate is there, no? That is the plus point. Okay, so always which is in small amount, which is moderate, so we enjoy a lot. So, so the trend is what? Trend of electronegativity, and the group 16th is from top to bottom it decreases. So whereas from the bottom to top it increases. That means oxygen is the most electronegative in this family, and in particular it is the second most electronegative, soon after the fluorine. Fluorine is the boss of electronegativity. So fluorine will never play the role of what? A positive character. Never. We have not seen. But oxygen can play the role. Oxygen is the second topmost electronegative. So always it plays a negative role only, electronegative. But with the fluorine, because fluorine is the already branded. Yeah, it is number one. So in fluorine is not ready to for agreement, adjust. So I am negative, electronegative topmost. So oxygen, you become positive. So like that. So it happens agreement. So oxygen can play the role of electropositive with fluorine, but fluorine never. It is the highest in electronegativity, smallest in size. So therefore, number one on the modern periodic table. In the same way, the top electropositive is francium, left bottom. Okay. So these two are the top electropositive, the top electronegative elements on the modern periodic table, and the rest all in between, depending on the position and the structure part. So I think we studied today some trends in group 16. Now there are some important trends are there which are related to the chemical properties. They are called as chemical trends, not physical trends. Now, all these what we studied just now, all these are physical trends. So in the next session, which is the most important, where we learn some other trends which are playing role in the chemical properties of group 16th, and then we move to the individual molecules, their preparation, property and use, and we will wind up this 16th also, and 17th is left, and 18th is very small, that is noble gas, no, so it will not give any property, but under some strong condition we have seen some xenon compounds are there. So only structure part we will see the in the group 18th, so that will wind up the P block. So I think today I am going to wind up a discussion, and regarding today's physical trends or general trends of group 16th. So if at all any clarification you need, I am ready. Sandeep?
Sir?
Clear? Trends?
Clear.
Very clear. Very
Clear.
easy. Very easy, because once you understand the electron movement, so understanding electron is understanding chemistry. Electron is the most naughty and the most intelligent particle. So let's not use the word naughty, because naughty means active. So take it as active.
Yes.
Like our Vivek, like our Sandeep, like our
Today Vikram Batra birthday also, sir.
oh,
Vikas said.
Yes, sir, it is his birthday.
is it? Oh,
Yes.
Kiran birthday, Vikram.
good. So we wish him anime. This is one movie, no, on Amazon.
Yes, sir.
Shesha.
So Shesha.
Shesha.
So he, share, Indian share.
Yep.
So who can fight till simply he will not fight. He will fight with a purpose. He will fight so that the next member will get a victory guarantee. So wishing him very best. So today very good news, good things, good happenings.
Sir,
Yeah.
opening of school.
Question mark for us also, because
No
we don't
clue,
get
sir.
any information from the society now. So we ask the principal will ask society. So unless we get a clear cut information, we can't say that on this day only exactly. But hopes are there.
Yes.
Unless sir has gone, in one of the meetings, that the school is going to reopen. We are going to have physical classes. That what sir has going to hint, and we are also ready mentally. So we are ready. We are ready to welcome you. Okay. Only thing is there are some formalities. SOPs are there. So all those standard operating procedure you have to follow, so that everybody is safe. Okay, then I think we'll wind up today's session, a small session on general trends, and tomorrow some important trends we'll discuss. Till then, have a nice time, and go for some additional practice, because November, in the November month, we are going to have term 1 examination as per the CBSE new plan. So therefore, before the November only, we'll discuss a question paper pattern.
Sir, in this electron gain enthalpy, sir,
Huh.
minus sign indicates that it
More
is
the minus value, easier is the addition of electron.
means minus 174 for polonium, sir. Then it will accept easily, sir.
You compare, you tell one more figure.
Compared to oxygen.
Minus.
It compared to oxygen.
Yeah.
Yes.
Oxygen is small size, you know.
Yes, sir.
In the small ball, you fix some 8 electrons, and in the bigger ball, you fix the 8 electrons, same 8 electrons outermost. Okay. So in the small ball, 8 electrons are confined to the small region area. So they sit close. In one room, you make to sit some 20 boys. Same size room, size is same. Then 40. So very difficult, no? Very difficult to. So
So that,
what is
but
it?
minus indicates
Minus indicates what? Minus indicates minus.
removal of energy, heat.
Yeah. So lesser the
That one.
value of minus. Okay. So
Yes.
if it is having larger the negative value, means what? Easier is the electron entry into the structure.
Yes.
That is the meaning. Okay. Then, so I think we'll wind up. So thank you, Vivek and team,
Yes.
and thank you, birthday boys, and Anand Hitnali. So sprint between Anand Hitnali along with Vivek team. So many will cross the that mark. So I think out of 38, 76, nearly 70 plus boys will cross that line with a full Josh. So that is the history created, and history is very difficult to break. So such a record we are waiting. Let us see in the available pandemic situation what best can be done at your level, at our level, in your area, what you will get, what we supply. So ultimately, it is teamwork that wins the what available condition. So with this, please keep in touch. November is waiting for you for the term one. So don't waste a single minute. This year you sacrifice. Okay. So the more you sacrifice your life this year, it becomes more sacrifice, sucrose, sweet. Okay. So sacrifice or sacrificing our life. So with this, I am going to wind today's session and thank you one and all.
Thank you, sir.